So I wanted to welcome you all to this webinar, which is all about preparing and optimize CAD models in Blender with our Rapid Pipeline system. This is the second in a series of webinars that we're doing. The first one was all about our plugin in 3ds Max, and this time we're going to talk about Blender and how to optimize your CAD models using our toolset. So thanks for coming, and let's go ahead and get started here. So a little bit about me. I'm a senior 3D technical artist here at DGG. I've been here for a couple of years. Before that, I was 6 years at Wayfair, leading their 3D team there in rendering and doing real-time optimizations. And before that, about 20 years in game development as an artist. So Rapid Pipeline, what is this thing all about? It's basically, we have this whole system for working with 3D assets. And you can basically convert to different formats, pull things in a variety of different ways, and do all kinds of optimizations and processing of those 3D models. Basically, it's all this processing things that you can do to models to make them so that they work in a variety of contexts. Either whether you're pulling in CAD models and you want to render beauty shots of those, you need to do a lot of different kinds of things to the CAD model if you actually get it to render properly. Assign UVs, make materials, optimize, remove all kinds of unseen faces that you don't need. All those kinds of things are really important. And then it becomes doubly important when you want to export out to a real-time format. So something that renders on a web viewer. And then it has to be really performant. And then if you're going out to, say, augmented reality or virtual reality, then it becomes even more important to optimize your assets because virtual reality is rendering two screens, at least 60 frames per second. So that's 120 times it has to render your model. It has to be super performant. And CAD assets generally are not performant. They're made to be really high res for manufacturing purposes and design review, those kinds of things. So it's a really different kind of need that you need for rendering and for real time than you need for CAD. So we're going to talk about that today and how to actually take your assets and do the processing that you need to do in order to get them in the right format. So thankfully, we have these integrations for Rapid Pipeline that bring them directly into your digital content creation tools. So we have an integration for 3ds Max, for Maya, for Blender, and for Unreal, and also Substance Painter. So each of these tools, you can bring in CAD models and automatically process them in a way that sets them up for doing all these kinds of processing tasks that you might need to do on assets. And it makes it really easy to do, and it's not onerous to get them between different applications because it's all sharing this core engine that runs in the background. And that's what the Rapid Pipeline engine is. It's basically a command line tool that runs in the background behind these applications. And we exchange data between the application and our runtime using different formats depending on which tool it is and what kind of formats it supports best. Right now, FBX is the format of choice for a lot of tools, but that's being phased out. Autodesk has definitely talked about how there are security holes in FBX and it's really an aging format. It's probably better to replace it. And so they're moving towards USD as the new format of choice. It's still pretty early in the USD kind of ecosystem. And so we're also working with USD. We support USD in our system, but not all the applications support it really well. So right now, we use FBX in Maya and Max to exchange with our internal system. And then we use GLTF in Unreal and Blender to exchange that information. But in the future, we're hoping to use USD and OpenPBR and Material X for handling that kind of data because it's just much richer and an easier way to transition data. So let's hop into Blender and take a look at how this works. So what's in Blender, we have these integrations that go on, and Rapid Pipeline is one of those. And it just shows up on your shelf here. So it's just another option that you can pull open. And it's resizable. So you've got all your actions here. You've got import and export, and then all the various other things that you might need to do to adjust the interface. But basically, this is how we import CAD assets directly into Blender. So I'm going to go ahead and delete the other junk that's in there. I don't need the default things. And I'm going to go ahead and import a CAD file. So right away, when I import, I've got all my folders here, right? Standard Blender things. But then we've got our sidebar here with various tools for handling imported data. And basically you can import at the top level, import a CAD file, and we've got options specifically for CAD. But then we've also got import files options for things that are not CAD files. So, FBX files, OBJ files, GLTF, etc. These have other options that are specific to those formats, like USD has various options, and there's a normal map flip for FBX files, that kind of thing. But we'll be talking mostly about the CAD import stuff. And then we have some other things that are basically, do you want to apply UVs before you import the model or when you import? And that's a quick way to add UVs in various different layouts. So for the CAD files, we've got tessellation resolution, which basically handles how detailed is the model going to be. When you import a CAD file, you're basically working with a parametric data in a CAD format, and it's not resolution dependent in a way. But you need to tessellate it, you need to convert it into triangles to make it something that works across all different render engines, and especially for real time. We offer a whole bunch of options here for how fine you want to optimize that when you bring it in. And generally, the default fine is pretty good, but you can, if it doesn't have enough resolution, you can go for extra fine, which gives more detail. So let's take a look at a pre-created example, because I think it takes this is a 400 megabyte step file, and it takes about a minute and a half to pull it in. I don't want you to wait, but it is pretty fast, but a minute and a half was slow for a webinar. So I pulled all these in advance, and these show the basic resolutions that you have when you import. So you have extra fine, you have fine, which is the default, and then you have medium and medium. Let's look at the triangle count first of all. So for extra fine, we've got 2 million triangles, and that's pretty good. That's a good resolution, I think, for working with this kind of data. And fine is fine at 1.2 million. Medium is 634K. Coarse is 420K. And it's dependent on the model and what the patches are that make up the model and how they tessellate. But in this case, extra coarse is down to 339K. And as you can see, it's pretty coarse, right? But it might work for your case if you're working with, say, proxies, or it's a background object and I don't really care about detail. But in general, I want to come in at a decent resolution to do some processing. Because, for example, if I took this file, this is 340K, but it's pretty darn blocky. But if I actually took this file, a super high res one, I can decimate it down to 340K, and it'll look a lot better than this because it's using this high-res source data to figure out all the curvature. So let's go ahead and do that. Let's use one of these actions. After we've imported, we can grab various tools to process the CAD data and get it to a reasonable level. So here we've got just the decimate functions. And say if I set this to 340,000, which is the same as the super coarse option down here. And I think I'll just leave all the rest of the defaults and hit run. And what's going to happen here is that it uses the selected items that I have, it exports it out to our runtime in the background and gives you a process log that shows you what it's doing. So it saved this out to a folder as a GLB file, and then it's going ahead and doing the decimation to the target that I chose, right? And it's giving you a progress bar. And the other thing we have here is a deviation percentage. And what that does is it looks at the original CAD surface or the original mesh surface, and it compares it against the decimated surface that's down to this number, and then sees, hey, how close am I to the original surface? Can I get even lower if there are really flat parts of it that don't need any triangles? So for example, this is the upper target of what we're going to go. That's the maximum number of triangles that you're going to get. And deviation percentage is going to say, oh, based on this quality level, can I get even lower than that? So here it is, it finished the file. And what it's done is it's hidden, let's look at the outliner here. It's hidden the original asset that I had. I'm going to hide all the, and just minimize these so we can see. But it's basically hidden the files the objects that we'd selected before. So they're still in the file. They're not gone. I can unhide them and use them. But it's showing the processed files, the processed meshes. So let's put those over here alongside the extra course. And you can see if we do the statistics here and we select these guys, it's under 340K. And it's a lot better looking. We turn off the wireframe, for example, and get in there. We can see really that starting from high-res data and optimizing it down to our target is really better than using the coarse input option. If you want to get down to that layer, that level of triangles, it's better generally to start with the higher quality source and then optimize down. So anyway, that's the basics of the resolution parameter and how that works. So we can unhide that guy. Let's turn on the triangles again. So another thing that's important here is when you're importing your assets, let's reset this and get a new file. And let's delete the sample stuff and open the RapidPipeline tray and go back to import. And here I'm going to try importing another thing and show off the next thing, which is the next option here is CAD sewing tolerance. And basically what that is if you have multiple patches on your model and things are made of multiple pieces, it'll try to basically sew those together in a logical way based on the material. So I'm going to set that to 0 to basically disable it and show you what you get without sewing together the different patches that come in. And I'm going to choose this door trim file. It's fairly small. It's only 500K. But basically it's a door design and it's made of a bunch of patches. So when I import this, it's going to go out to the runtime and then pull that file in. And what it's got here is if we do the statistics here, let's see, is statistics on? Let's turn it on. We've got 72 objects in this scene, and this thing is made up of a whole bunch of different little parts, right? You can kind of see them as I select them. And it's going to be not fun to edit this file for 3D rendering because I've got too many parts. So if I instead go back to import and choose the file, and this time I'm going to leave it at the default for the sewing tolerance. So it's going to try to find surfaces that are within 0.05 meters of each other, which is what, 5 centimeters? Is that right? And you can adjust that tolerance if it's too low or too high. The other thing I'm going to do is convert Z up to Y up. And that's because this guy is basically facing flat in the scene. So I think it was probably modeled in a CAD tool that was Y up, but in Blender, we are actually Z up, right? So it's a different orientation. So we can automatically fix that on import just by this option. So we're going to sew the patches together and we're going to convert to Z and Y up, and it's all just one button pressed. And here it pulls it in, it's pretty fast. And now we have just one object and it's the right orientation. So that's pretty simple. Converting the axis is really simple. You could just select all these things and rotate them, but why do that? The other thing that's nice about the patch thing is that this model basically has all one material. So it's attached all the parts together, even the trim. If the trim was a different material, it would keep those attached to each other, but not to the door metal parts. But this thing only has one material, so it's just automatically attached it all together. So let's look at a few more options here. So what else? Got remove T-junctions. And basically what that does is, let's pull up the documentation. I can show you how that works. Let's see. Here we've got the import files. Let's look at the import settings. So in here, we can look at the CAD sewing tolerance. That's the thing we looked at before. Here's remove T-junctions. So basically what happens is if you've got two patches that are next to each other and the edges are being sewn together, but there's extra tessellation on one patch than on the other, you're going to end up with sometimes these what are called T-junctions, and it's an extra vertex on one side that's connected, but on the other side is not connected. And when you decimate this or start to move things around, you sometimes get these cracks in between things. And so that's what this function does, is it tries to remove these things by edge collapsing or by adding points in order to figure out how to make it a contiguous surface instead of having these gaps. So what else? Oh, so expert tessellation. This is really cool. In the import options, you've got the option to choose between those 5 different levels, but you can also choose custom, and you can go in and choose how much deviation and how much angle options between edges to get that extra fine control. So if these 5 presets aren't enough to get you the detail you want on the incoming file, you can actually go in and customize it by hand. And what's cool is that you've got these 3 basic controls in green here. The CAD surface is the original, and that's a parametric surface, so it really isn't tessellated in the CAD tool, but you need it to be tessellated to render it and to do real time. So the surface deviation looks at the difference between the tessellated version and the CAD surface, and you can control how fine of a deviation that is, so that, say, it'll tessellate it more or tessellate it less based on what you want. And then you've got edge length and match angle between tessellation surfaces, and all those kind of affect how a surface comes in and how much detail. So anyway, you've got all those controls to adjust your file as you want. And what else? Oh, so winding order. That's a really cool one. So let's pull up an image to explain what that is. If we go over here, so this CAD file basically comes in with patches that are oriented the wrong way. And what happens is when they come into Blender or any other 3D tool, some of these surfaces are going to be inverted. And if you try to render, say, ambient occlusion for that, and bake ambient occlusion with our tools, the surface is going to be facing the wrong way, and the ambient occlusion is going to be super dark. And it's not only problematic for ambient occlusion, but also just for rendering an asset. So this is rendered, I think, in the Substance 3D viewer. And basically some of these patches are inverted, and you get these seams and weird kind of lighting discontinuities because the patches are inverted. Even though they're rendered double-sided in a path tracer, you're still going to get these kind of weird intersections where things are facing the wrong way. And so we have, thankfully, a tool that fixes this automatically. So let's look again at the tessellation example, and I'll show how that works in context. So for example, if you, by default, it doesn't look like it's wrong, right? These surfaces look like they're fine, but let's hide everything except for the high res one that I like. So Control Alt and select it and hit home. So it looks fine, but it's rendering double-sided, and that's why. So if we turn on backface culling in the view settings, then you'll see it's really, things are facing inside out. The other way to look too at this and to see whether faces are facing inside out in Blender is to use the viewport settings to turn on face orientation. And this basically marks in red surfaces that are facing the wrong way. I think in Blender 4, Blender 5, and Blender 4, it was, blue was facing the right way and red was facing the wrong way. So there's just another way to check visually, hey, are things incorrect in my file? And that's because when the CAD file was made, these pieces were probably negatively scaled or mirrored in some way in order to make duplicates and then attach together, that kind of thing. And that causes that kind of flipping when you want to tessellate it. So to fix it, basically, I can go into RapidPipeline and use this cleanup mesh option since it's already imported, or you can do it on import. It's up to you. But basically, it's this option right here, fix winding order. We have some other things in here. Hey, do I want to recompute the normals? I don't really need to do that because the file came in fine with good tessellation. And you want to merge things together or how that works. But right now, I'm just going to fix the winding order. So what you can do is you can select specific pieces that I want to fix, or you can just deselect and it'll work on all the visible pieces. So I have all these other resolutions in here, but they're all hidden. So it's not going to work on those. It's just going to work on what's visible. So I hit run, and basically it's going to export that file back out to a GLB. It's going to do the processing in our backend CLI. And oh, you know what? It's still on the other one. Let's cancel that and reset that and reopen up this file. So it was still on the decimate action. But let's go ahead and select this thing again. Let's control click, control alt, home to get it centered again. I'm going to go in perspective view. I'm going to turn off the wireframe and turn on the face orientation so I can see that again. So let's go back into RapidPipeline, make sure I'm in cleanup mesh. Okay, I'm going to turn off these other options. I'm going to turn on fixed winding order, so I only want to affect that. And now run it. Now it's going to export that file out and do the processing I want. And again, it's 2 million triangles, so it takes a little bit of time, but it's not that bad. It already has a file stored in memory from when we imported it. So it doesn't have to do that much to it. And so it's done and it's popped it in. And now we know face orientation is still on and nothing's turned red, which is awesome. It's basically hidden the file, the original mesh that we worked on, and it's created these new meshes, which are now facing the correct direction. Oops, my little mouse wheel's goofing off. So now it's all facing the right direction. And if we bake ambient occlusion and stuff, we wouldn't get those dark patches that we got before, which is super helpful. So winding order is something, it's a pain to fix it manually, but here it's all automated. It's just one checkbox and hitting a run. So what else? Another thing that's cool here is that we can do what's called occlusion culling. So for example, on my model here, I'm going to turn on, let's see the geometry. So you can see my selection. And this has a material on it. Pull up the material dialog here. And I'm going to make a new material here. And I'm going to call it glass. And I'm going to assign a transparency to this surface. Oh, turn on material preview so I can see it. So now I have, get the geometry out of the way. So now I have a partially transparent glass. I'm going to go ahead and assign it to these other surfaces so that I have glass in the car, right? And this is going to help me show that, hey, inside this car, there's a bunch of geometry in there. And sometimes you want that geometry in there, and sometimes you don't. It really depends on your use case. For VR, for example, it's going to be, performance is going to be key. And I probably don't want all that extra geometry inside of it. I can make the glass be just dark and not transparent. For example, I could set this to be just a tinted glass look, right? And I want to cull away all that stuff that's inside there because that's just not seen. But normally it is seen. And I want to cull away the things that are maybe inside the model that are parts that I don't want to see, that I'm never going to see, right? So if I move this piece up, there's all kinds of parts inside of here that I don't need to see if the model, if I never open the hood, for example. And there's a really cool function here that basically takes care of that for you. And what it is a tool called remove occluded parts. And what this does is, you see in the example image here, there's a microwave and it's got hidden engine parts inside of it. So you're basically able to automatically remove those. But this function is super smart in that it basically knows when you have transparent surfaces, you can see through those, and there are parts inside of the model that it should not remove because they can be seen behind glass. So these parts won't be removed by that function unless you say, hey, ignore the glass, remove everything. So let's do it without that first and then see what happens. And we'll look at the triangle count right now, it's 2 million. So if we run this without ignoring the transparency, basically saying, hey, glass is important. Don't kill these parts that you can see, but kill all the other parts that I can't see through the glass or through opaque parts of the model. And so what it does is it computes the visibility of all those parts. And it's going to hide the model, the parts that I had, and it's going to unhide, basically create a new copy of all these parts. And what we've gotten down to is 1.6 million triangles, as opposed to before we were at 2 million, just by occluding parts and not doing any decimation or anything, but occluding parts that we can't see from the outside, even through the glass. So let's do it again. Let's do it with that option that we had. So let's do it. Say, hey, I ignore transparency. I want to remove everything that's behind any other polygons, even if they're transparent. And now what it's going to do is take this selection and it's going to run it out and it's going to remove all the parts inside. And that's, again, if you don't care about glass, right? I don't have any transparency. I don't really care about it. Then it's going to remove all those parts that are behind other parts. And it's going to pull in the export file when it's done, and then we'll be able to see it in the view. There we are. Okay, so now it's just removed all those parts inside, so it's super efficient. So if this material, for example, was set to opaque, right, then it wouldn't matter. And if we select all the parts, so A, I think it is, then we're down to 1,000,001, which is great. And all without doing any changes to the tessellation. So that's super valuable, right? That basically handles all that removing that's tedious to do manually, but this calculates it all automatically, which is super helpful. Let's see what else. We can look at some other import options here and see what else we have here. So we have some other things which are like, there's an automatic mesh simplification that can be done. By default, this is set to 10 million, right? If we look at these zeros, that's 10 million triangles. So that's the maximum. So if you have a super high detailed CAD model and you don't want to bog down Blender and basically destroy performance, you can basically tell it to decimate it. After tessellating, it then decimates to get under this number. By default, we set it to a really high number, so it doesn't do any kind of that. And it basically is just tessellating the patches to whatever resolution you set. But this way you can set an upper limit so that you don't get any kind of performance problems. So that's really helpful too. So that's the basics of how I'm going to look at our time here and make sure that I'm doing all right. Yeah, we're at halftime here. Maybe I should just grab some questions. Do we have any questions from the audience? Let's see. Does it show me how that works? Where are my options? There's Q&A. Nice. All right, so here we go. It drops questions. Okay, so is it better to remove occluded parts and then decimate mesh, or vice versa, or it doesn't matter? Yeah, so that's a great question, right? If you remove occluded parts first and then decimate, that kind of makes sense because you're removing things that you can never see, right? And that doesn't add to your decimation budget. So say you have a client that says, hey, I want everything down to 100K triangles, and that's my limit, right? Then you can remove all those parts that you would never see, and they don't add to your 100K budget, and they're unseen anyway. So it's better to do it beforehand. But the other thing that's cool too is that you can look at occluded options. There are options for when you remove occluded parts to decide how heavily do you want to cull all those parts away. So you can look at it basically per part, basically looks at whole parts when it tries to remove them. So it looks at all the connected triangles in a surface and says, is a certain percentage of this invisible behind other parts, and thus I can remove it. And you can set that percentage, that visibility percentage. So say if this is mostly inside the surface, if we go to our move icon here and we move it so it's mostly inside the glass, right? And only 10% of it is outside, you can say, hey, I don't care. If it's 90% inside the surface, I want you to cull the whole thing. And so that's what this does is by part says it looks at a whole part, says, is it 90% invisible behind things? Then go ahead and remove the whole thing. What you can do as well is you can turn that off and it does it per triangle. So now it will try to it'll try to remove any of the triangles that are wholly inside and only leave the triangles that are outside. So if we turn on the geometry, for example, you can see this thing is crazy tessellated, so there's a lot of triangles here. But it'll try to keep all the triangles that are visible on the outside. So if we do that, so let's try that. Let's just do that. Turn off visibility by part and run this on this one selected object. And when it's done, did I do it right? Oh, I didn't do it right. Anyway, the idea is that it's looking at it per triangle basis as opposed to a per part basis. And so when you do that, you might end up with a really jagged edge on your model. And then you decimate, that might cause gaps between this and the original surface. And so that can be problematic in the past if you're trying to remove every triangle that's invisible, but then you decimate it, you're going to get gaps. And so I think it's better to remove per part at choosing your threshold and then decimate it down. So let's see what other questions we have. I hope that answered it correctly. If it didn't, ask another question. Happy to talk more about it. So here we go. With the remove and occluded parts option, does it only remove meshes as a whole? Yeah, so I think I talked about that just now. It can create new meshes based on what it's occluded or not, or should user remove occluded first with sewing tolerance and then sew. Yeah, I think sewing tolerance is good to do up front because it really depends on your situation, right? When we had the car door, for example, that doesn't really have occlusion because it's just one door, but it's made of different parts, and you can decide if you don't want to do any of that sewing together. You can say, hey, just disable it, and I don't want to sew it at all. You can actually do that sewing later by doing vertex merging. So you could do no sewing, import the file, occlude based on parts, and then decide from what's remaining, go ahead and merge those together. And that's all part of the decimate mesh function. You can choose how to basically control how these things get merged together, or the cleanup mesh, right? Do a vertex merge distance and say, in meters, how close are those surfaces together before I want to start to merge them, 1 millimeter, or however, what that distance is. So that might be a really good way to do it. And you can just follow up by doing different actions in different orders. Okay, so that's that one. Let's see what else. We did that one. We did that. Let's see. What's the difference between step per plugin for Blender? Oh, step per plugin. I haven't looked at step per. I'm curious about that. I'll have to look at that one and see. Basically, we use what's called hoops on the back end, which is a third-party set of tools for handling CAD files. And basically, it handles a huge number of CAD files, which is really freaking cool. It's a gazillion formats. If I look at, let's see, the options for file types, oh, it would be in our documentation. So let's go look at that because that lists all the files. So here, where's my web browser? There we are. All right, so when we look at the format and material support, move this out of the way, for all these CAD files. So we offer over 70 different CAD file options. It's not just step files. I'll have to look and see what are the options in there. The other thing is we have all kinds of different resolution settings for it and all the other options that you have in the plugin for handling all these files. Yeah, I'll have to look and see. That might be a really good thing to look at. Thanks for mentioning that one. Should pull it up and save that one off. So I think we got the answer there. Okay, and so do you have an automated way? So where's my window? Here it is. Do you have an automated way to recognize parts sharing the same geometry, shared mesh data, for example, screws, etc.? Automated way to recognize parts sharing the same geometry. Yeah, if it's all part of the same node. So for example, let's close these and see, this is a single mesh node right here, right? It's all just one object. This is a separate object. They're separate nodes in the hierarchy tree here. Ah, my mouse wheel. There we go. These are considered single objects, right? And when you occlude, you can occlude parts, but you can also remove small parts. And so the way this works is it works off of, it doesn't have to be in the same node. It can be separate nodes, or it can be within one node. So we can look at small parts that are already attached to this node and remove them based on the fact that they don't have connected vertices. For example, if this is attached to the wheel and it's not a separate node, it's still, the vertices are not connected. The vertices are not welded to this surface. It's a contiguously separate mesh. Our tool basically looks at that and says, oh, that's a whole part that should be removed. It's under 1 centimeter across. Go ahead and remove it. And you can set this limit, of course. You can set it to 0.02. So anything that's lower than 2 centimeters, remove it out. And it'll remove whole nodes like this, or parts of other nodes that are not connected, but are whole elements. In 3ds Max terms, what we call this an element, right? A mesh element. It's still part of the same node, right? Same mesh node, but it's a separate element within that. And so that's how the removing small parts works. And hopefully that answered your question. So what else? Or yeah, you can think of them as instances, right? Different parts within the model. How are we doing for time here? Let's look. 11:41. Oh, we can talk about a few other things. Let's present this so it's nice and big. So we talked about the resolution, right? And these are examples of that. And we talked about custom tessellation. So you can choose to go even finer or even coarser if you want based on your surfaces. And then we have some cool features that are in progress, which are really exciting to see. Now, this software, RapidPipeline, is continually being developed, and we listen really closely to our customers and what they want. And a common refrain that we've heard again and again is that quad meshes are really important to people. And that's true as a 3D artist. I don't work with triangulated data. I know triangulated data is really important for the end result because when you go out to real time, everything's triangles anyway. And you want to make sure that things are triangled before or triangulated before you bake your normal maps, for example, because the winding order of quads is going to change depending on which exporter you use, and that can mess up your normal map. So triangles are really important, right? But they're not very easy to edit. And quads give you really nice, easy edge flow so that you can select things and you can do, say, weighting with skin modifiers, etc. It's just a lot easier to handle data. And so we've got preliminary results with quadifying assets and working on quads. And we're continually working on that right now as a feature. So that's coming soon. And then another feature that's really cool is hole filling. So, for example, you have in really some complex CAD assets, you have screw holes and like other things that are sticking inside your model. I don't need all that detail often when I'm using it as a render model, or it's a super complex giant engine, for example, with all those little bolts and nuts and all the holes that they go in with the screw threads and all that stuff. So this automatically looks at surfaces that are inside other surfaces that are basically conical in shape or cylindrical in shape, will remove the interior geometry and then automatically cap the holes and use the same material and UVs from the existing surface around it. And that's super useful. So let's pull up an example here. I've got some 3D models already. We can open those up and tumble them. Let's see. Let's see, where is it? Here's the quantified one. Let's look at that one because that's cool. So here it is quantified at different resolutions, right? We've got extra fine over here, which has been quantified. And it's going to do some triangles because certain quads are at different resolution than other parts. And so it's got to still bridge between those, but it's going to keep a contiguous surface when it does that because it's not going to make a surface that's not valid. So it's a necessary evil, right? You're always going to end up with some kind of triangles in your surface. But in general, it does a really good job of kind of figuring out where those quads are and what needs to stay as triangles and what can be quads, which just makes it that much easier to edit. So that's the extra fine. This, I think, is medium tessellation quantified. And again, your resolution is going to change between different parts, so it's going to have to bridge between those. When it renders, it's pretty smooth and solid. And then we've got, I think this is extra coarse or coarse. And it's done a pretty good job of handling it, even with these like weird surfaces where I think it's the numbers on the carafe. You can't really see them here, but when you have a material and all that, it's going to show those numbers. So that's a quantify thing. Let's look at the other one, which was the remove, the kind of the cleanup surfaces. So don't save that. Here's the defeaturing and the hole filling. So what's happened here is that those interior surfaces are now gone and it's patched up the surface. And the other thing that's cool here is that it's off axis too. You've got off axis holes and it can handle that as well. It's not just axis aligned holes. It's looking at surfaces in any orientation and trying to remove those and patch them up as needed. Now this is in development. It's still ongoing and we're improving things as we go along, but it's pretty solid so far. We're looking at all different kinds of test cases. So if you have features like that that are really important to you and they're interesting to you and that you need in a tool set, those are things that we love to hear about because they're things that are probably important for a lot of different customers. So there's a lot here that I haven't touched on. I want you to be able to go check this stuff out and see what's going on. So, that's our Q&A. Head over to the website and check it out. There's a free trial that you can play with all these tools and see how they work for you. And it's 14 days and no limits, basically. You can use all the tools that we have. So let's look on the website here and see. Here's the platform itself. And what this has is all kinds of cool features for pulling things. And this is the web platform. So this runs on our hardware. When you have one of the integrations, those run directly on your own hardware and it's not sending anything to the web. So that's useful. If I have a proprietary data from a client and I don't want to share it across the web, using one of these integrations, all the processing is local. None of it goes to the web. The only thing that goes to the web is a license check. And basically it looks for your authentication token and does that at the start. And then you're not looking at the web again. So your assets stay local on your machine and aren't sent to the web. All that processing is local. If you don't want to use a DCC, you can use the web platform where you can import assets. You can make all the optimization choices that you want for this asset. And you can also make embeds, which are really cool. So you can go ahead and make a live 3D embed that you can share with your clients. And this is a public URL that you can send and they can look at it also in AR and VR. If you have a phone and you're looking at this URL, you can pull this thing up in AR and walk around it, which is super cool. So that's the web platform, right? It has the integrations. You can download those, assign different seats, and it's pretty cool. Oh, we can also pull in V-Ray assets. So that's pretty cool too. You can actually import Max files that have V-Ray materials and it automatically converts it into any format that you choose, right? So you've got a bunch of different formats that you can convert to, but right out of the gate, I get a GLTF file that has sheen, right? The original V-Ray material had the sheen Fresnel effect to give that soft fabric. That's converted directly into GLTF sheen extension. So all those kinds of things are supported. It's a pretty cool, deep conversion. Okay, so we have another question. Let's see. I think we got all our questions answered, right? I think we're all good. So anyway, I just wanted to thank you for coming, and I think we covered pretty much all of it. If you have any further questions, reach out. We're always happy to chat and to feel out your ideas and see if you have ideas. Definitely contact us and let us know what you're thinking or how the trial works for you and what options make sense to add or things that just don't make sense, right? We'd spend a lot of time on our documentation and try to make it really clear how to actually use the tools. So you've got tutorials that run through Blender and how to actually use it, right? How to install it, how to import, and how to use these processing tools, and hopefully the videos help, there's always going to be questions. Feel free to contact us. The other cool thing too I wanted to mention before we finish up is we have this chat button on the website in the app. And this thing basically goes to people. This goes to real people. It's not an AI agent that's going to lead you astray. It's going to send, it goes right to people, and we answer these directly with help for you on your problems. And you can either chat here or you can continue via email. So that's helpful. There we are. All right. So anyway, thanks for coming. Appreciate your eyeballs, and send us any questions you have. Take care.